Hello, welcome to the third and final part of our first lesson in Unit 4 of our Grade 10 academic math class. This is graphing quadratics in vertex form. So we have so far gone over the terminology of quadratics and what a quadratic looks like, some of its key features, and then how to graph it using what I call the plot pattern, which is understanding that wherever your vertex is, from our vertex, our parabola has a graphing pattern of going out one from the vertex and up one squared, out 2 from the vertex, up 2 squared, which is 4, out 3 from the vertex, and up 3 squared, which is 9. So that's a predictable pattern for quadratics. What we're going to throw at you right now is something that maybe you noticed and maybe you didn't along the way. But when we were graphing the quadratics just above this, so when we were graphing these two right here, what I want you to notice is that our a values were 1 or -1, which means that we can take the out 1 up 1 squared, out 2 up 2 squared, and out 3 up 3 squared at face value. But if the a value is something other than 1 or -1, so how do we go about graphing when a is something other than 1 or -1? Well, what I'd like you to consider is that, and maybe we'll do this sort of looking at our first example. So our first example is y equals -3 bracket x minus 7 all squared plus 9. So this a value here tells us two things. It tells us that our parabola will be opening down. So maybe we'll just put that here because we're already looking at it. So our parabola is going to be opening down. That's what a negative a value tells you. It tells you that because our parabola is going to be opening down, it will have a maximum value. But the 3 part of it, so the negative just tells you that one thing. Now just looking at the number piece, the number 3 tells you that if we think about it, what's happening between the 3, I'm just going to change up my colors here, what's happening between the 3 and the x minus 7 all squared? That's multiply. So what's happening is this parabola, it won't be growing by 1, 4, and 9 every time. It will be growing by 1, 4, and 9 3 times faster. So here's how I'd like us to consider writing this out. I would like you to write down, if you would, 1, 4, 9. Just kind of on the side over here. And remember, the part that I'm not going to write down is that from our vertex, we're going out 1 in both directions. We're going out 2 in both directions, and we're going out 3. This is from our vertex in both directions. So if our a value were 1, every one of these values would be amplified by 1, which just of course results in the same thing that we started with, because anything times 1 is just going to be 1. In this case, however, it's not going to be increasing by a factor of 1, it will be amplified by a factor of 3, which changes the amounts that we go up when we go out 1 in both directions, 2 in both directions, and 3 in both directions. So if we go out 1, we're going to be going up 3 for this particular parabola. And from our vertex, if we go out 2, then we're going to be going up 12. And I guess this is opening down, so we'll be going down 12 units. And instead of going out 3 and down 9, we're going to be going out 3, down 9 times 3, which gives us 27. So this little thing that I've written here, this little sort of calculation square, I highly recommend that you write this down every single time when you're graphing a parabola. It just prevents you from forgetting that the plot pattern is amplified by whatever our a value happens to be. In this case, 3. Okay, so let's get back to the graphing of this one. The vertex for this particular parabola is x minus, remember that's different than how it appears, whoops, different than how it appears, so this will be a positive 7 here, and there are positive 9, so our vertex will be 7 and 9, as we can see, and the axis of symmetry is x equals h, which is x equals 7 in this question. So from here, let's set about getting our vertex on the grid. So our vertex is going to be 7 and 9. So 7 and 9, that's up here. So there's 7, 9. Now again, there's not necessarily a right order to put everything on this graph. For example, I've got my vertex on here. There's no reason that if I'm feeling it, I can just put on my axis of symmetry at the same time. Maybe that's helpful to you. Again, it's not about a particular order to things being done here. So this was x equals 7 is how I labeled my axis of symmetry. So there we have it. Now let's look at the plot pattern. And again, I want to remind you that our normal plot pattern with an a value equal to 1 is right here. Out 1, up 1 squared, which is 1. Out 2 from the vertex, up 2 squared, which is 4. Out 3 from our vertex, and up 3 squared, which is 9. But our a value requires us to amplify those 3 output values by 3, which is our a value in this case. So let's go to our graph. Let's get my color consistent here. So from my vertex, which I have on here, normally I would go out 1, down 1, and put a dot. However, this is now going to be 3 times farther down. So instead of going out 1 and down 1, I'm going to go out 1, down 1 times 3, which puts us here. And again, on both sides, that's going to happen. Now normally, I would go out 2, 1, 2, and down 1, 2, 3, 4, pop it there. However, as we saw in our chart, this is actually going to be 3 times farther down than that. So this is going to actually be out 2, down 12 in this case. So that's 3, 4, 5, 6, 7, 8, 9, 10, 11, there's 12. And again, I'm 2 out from my vertex, so 2 out from there. I can put the corresponding point. Now you can tell by looking at this graph, I'm not going to get out 3, down 27 onto this thing, so I'm just going to leave it. At this point I have all of my points on the graph, so I am going to try my best to draw a curvy line through these guys. It is really not easy when your parabola is narrow like this, but there you go. Let's put some arrows on that thing. Now, normally I would label the x and y intercepts. None of these go through even integers that I can see, so I'm just going to leave that off. I am going to label our vertex at 7, 9, and I am going to label our equation as y equals -3 bracket x minus 7 all squared plus 9. And there we go. That is our parabola. We have a labeled vertex, labeled axis of symmetry, labeled equation, all the points labeled that are intercepts that can easily be done, and we have applied the appropriate plot pattern given that it's going to be amplified by 3. Hopefully that makes sense. I know it's a lot. Let's look at this second example before we call it a day. So same thing here. Here we have the quadratic relation y equals 1/2 x squared plus 5. Now this one looks a little bit different, so I'm going to actually rewrite this in a way that might help you see what our vertex is. So this is y equals 1/2 bracket x plus 0 all squared plus 5. So what you can see here, hopefully, is that if there isn't a number in the bracket, there was a number, it was actually 0. It just means that our vertex hasn't moved left or right, it's sort of staying in the same spot. So our vertex in this case would be 0 and 5. Our direction of opening, well, our a value here is positive, so our parabola will be opening up, which means that our parabola will also have a minimum value. Our parabola, its axis of symmetry is x equals h, which in this case is x equals 0. Okay, so let's get a little bit of this stuff on the graph, and then we can talk about how to actually do the plot pattern in this case. So 0, 5 is going to be our vertex. I'm going to change up my color here. So there's 0, 5. Give it a little label. I know my parabola is going to open up. So I am going to move my label down a little bit. There we go. And I'm going to put on my axis of symmetry right now too. So my axis of symmetry, again, if you're doing it right on the y-axis, I kind of just write it off to the side a little bit just so you can kind of see it. Obviously mine's in hot pink, so you can see mine, but when you're doing one on a piece of paper, sometimes it's hard to see. And that is going to be labeled x equals 0. Now let's talk about the plot pattern. So as we remember, over here, what we had was our parabola going up 1, up 4, and out 9 when it goes out 1 from the vertex in either direction, out 2 from the vertex in either direction, or out 3 from the vertex in either direction. But as I said, this needs to be amplified by whatever our a value is. And our a value here is actually 1/2, which means that our plot pattern is actually going to be happening half as quickly as when the a value is 1. So when you multiply this out, you end up with 1/2. You end up with 4/2, which is 2, and you end up with 9/2, which for graphing purposes is going to be 4.5. So let's get to our graph itself. So remember, normally we'd be going out 1 and up 1. This time we're going out 1 and up 1 times 1/2, which means we're actually only going to be going up 1/2. And again, that happens on both sides. Normally I'd be going out 2 and up 2 squared, which is 4. This time we're going out 2 and up 4 times 1/2, which means 2. There's 2, again, on both sides. Now normally we'd be going out 3 and up 9. This time we're going out 3 and up 9 times 1/2, which is 4.5. So there's 2, 4, and 1/2. And again, I'm doing this on both sides. So there is our parabola. I'm going to connect this as curvily as possible. Get some arrows on the end. And let's get some labels on here. So the parabola itself is y equals 1/2 x squared plus 5. And we've already labeled our vertex and our y-intercept. Our axis of symmetry is already labeled. We did that right at the beginning. So that's the gist of it. I know this was a really long lesson and there was a lot of stuff happening in it. So it's entirely new. Be patient with yourself while your brain rewires itself around this new information. Rewatch, rewatch, rewatch as much as you need to. Try the homework out. And if you have any questions, obviously email me. Let me know what I can do to help. Otherwise, hopefully the homework goes well, and I will see you in lesson number 2.